Okay, hello students. Today we'll continue chapter 14 and now we'll understand what do we mean by the closure of attributes. So, for example, if we have an attribute x and we need to define and uh, calculate the closure of this attribute, and we denote by the closure of attribute is x plus. So we have an attribute x and we need to compute the closure of this attribute, which we call x plus. So x plus is the closure of x under f. So we have an initial set of functional dependencies f, and from this f we need to calculate or determine the x plus or the closure of x under f, which is uh, the set of attributes that are functionally determined by x under f. Okay, and if we want to denote it in terms of set, x plus equals set of elements y such that x determines y belongs to f plus, or the set of or the closure of f. Okay, so x plus or the closure of this attribute is the set of all elements y such that the x determines y. This functional dependency belongs to f plus, which is the set of all functional dependencies, or the big F. Okay, so we have a theorem that x determines y. This functional dependency belongs to f plus if and only if y is subset of x plus or the closure of f. We can read this in two ways. The first way, if x determines y belongs to the functional dependency f plus, to the set of functional dependencies f plus, then we can deduce that y subset should be subset of x plus, or the set of attributes that are functionally determined by x under f. Or we can read it in another way. If y is subset of x plus, then uh, we can we can write that x determines y belongs to f plus. Now in the example we will understand it better. So how do we determine x plus, or the algorithm for computing x plus? First of all, our input will be f, which is a set of functional dependencies or set of initial functional dependencies, which is a set of attributes. Okay, so the input will be a set of functional dependencies f and a set of attribute x in R, and we want to determine x plus or the closure of x under f. So the output should be x plus. How do we begin? We begin by uh, first x plus is a set, as we said. This set will take elements in each iteration. In the first iteration, we assign it the value of x. So, if, for example, if x is one attribute, or for example, if x is two attributes, then x plus initially will take these two attributes. Then, after first iteration, second iteration, third iteration, x plus may become large, and when we finish all the functional dependencies given in this set, uh, we will finish computing x plus. So here we have a repeat operation, which means we have a loop. First of all, the old x plus will equals to x plus. Okay, and for each functional dependency y determines z in f, we will do the following. We will check if y is subset of the x plus, then we need to add to the x plus the z that is determined by y. So if y is subset of x plus, then we need to add z into x plus. This is determined by this assignment here. Okay, until x plus equals to the old x plus. We finish when x plus now becomes to the old one. So if the x plus remains the same as the initial one in this iteration, then now we will stop computing the x plus, and the final x plus will be the closure of x. Let's take an example and then we will reread this slide depending on this example. So for example, if we have this relation on with 5 columns A, B, C, G, H, and I. So this relation have or 6 columns A, B, C, G, H, and I, and we have X, a set of attributes only A and G, and we have a set of initial functional dependencies given here. The first functional dependency A determines B, and CG determines HI, and B determines H, and A determines C. And I want to determine or calculate X plus, which is the closure of AG. I want to determine the closure of AG. So as we said, in the initialization phase, we need to assign X plus to X, which is AG. The first step is assign X plus to AG. After that, we'll enter a loop on the elements of this F, or on the functional dependencies that we have. So in the first iteration, we will consider all the functional dependencies given in F. This first one, second one, third one, fourth functional dependency. We will loop on all of them in the first iteration. So, and we will check at the end of this iteration if X plus is changed. If X plus is changed from the initial one, then we will enter a second iteration on all of them. We will stop until X plus remains the same as the initial one. Let's take this example. So as we said, we take X plus initially equals to X, which is AG. Okay. Now we will consider the first functional dependency, A determines B. Okay. Now we will check if A is subset of X plus, then we will add B to X plus. And as we know, X plus is equals to AG. The first functional dependency said if A determines B. We check if A, or the left side of this functional dependency, is subset of X plus, which is AG, and this is true, A is subset of AG, then we will add B to AG. Then X plus becomes ABG. Then we will move to the second functional dependency, CG determines HI. This is the second functional dependency. And we will do the same thing. We check if CG is subset of the new X plus. Does CG subset of ABG? We see no. CG is not subset of ABG, so we will not add HI to ABG. So since CG is not a subset of X plus remains ABG. Now we'll move to the third functional dependency, B determines H. We will check if B is subset of X plus, and we will find that's it true, because B is subset of ABG. Then we will add the right side, which is H, to X plus, then X plus becomes ABGH. So since B is subset of X plus, then X plus becomes ABGH. This is the new X plus. Now we will move to the fourth functional dependency, A determines C, and we will check if A is subset of ABGH, then we will add the right side, which is C, to X plus. Okay, and we see here that A is subset of ABGH, then C will be added to X plus. So since A is subset of X plus, then X plus becomes ABCGH. we'll finish all we finish all the functional dependencies given in F, and when we finish them, we check if x plus is changed from the initial one, which is ABG. Because it is changed, we need another iteration. So the initial x plus in this iteration was ABG, and the final one is ABCGH. So x plus changes, then we need another iteration. Then we move to the second iteration here. So, and we loop again on all the functional dependencies. Now the initial x plus now becomes the new one from iteration 1. Okay, now we'll consider this x plus as an initial x plus. Okay, so we will consider A determines B, and now we'll check if A is subset of ABCGH, and we find that A is subset of ABCGH. Then we will add B to x plus, which is ABCGH. But we found that B is already found in x plus, then it will remain the same. Now we'll consider CG determines the HI. We check if CG is subset of x plus, and we found that CG is found in x plus. Then we will add HI into ABCGH, but H is already in ABCGH. Then we will add only I. Now x plus becomes ABCGHI. Okay, now we will move to the third FD, or functional dependency. B determines H. We found that B is subset of the new x plus, so we should add H, but H already in the x plus, so it remains the same. Then we'll consider A determines C. Because A is subset of ABCGH, then we should add C, but C is already in x plus, then x plus remains the same. Now we will check if x plus, if the new one or the final one is the same as the initial one, or it changes. We will see that the initial one and the final one are different. Then we need another iteration, a third iteration. In the third iteration, if we will loop over all of these functional dependency, we will find that there is no change to x plus, so then we exit. So we'll consider each FD, or functional dependency, in F again, but there is no change to x plus, then we will exit. So we'll take x plus as the final result we get, which is ABCGH. So AG plus, or x plus, the closure of AG is ABCGHI. Okay, so by this way we can calculate the closure of any attribute or set of attributes by looping over all the functional dependencies we have. We see that the performance of the algorithm is sensitive to the order of functional dependencies in F, because if the order of these functional dependencies changes, for example, this will be the first one, and this will be the second one, and this will be the third one, for example, then the computation of x plus will change, and it may be it will take more time, or it may take less time, according to the order of the functional dependencies given in F. So this is meant by the performance of the algorithm is sensitive to the order of FDs in F. Okay, now let's go back to this slide, which explains the algorithm. So we have as an input a set of functional dependencies F and a set of attributes X in R. So, and we need to compute X plus, which is the closure of X under F. So the first thing we will do is we will initialize X plus to X. Then we will enter a loop by in each loop we'll go for each functional dependency y determines z. If we found that y is subset of x plus, then we will add z into x plus. So x plus now becomes x plus union z. Because y is subset of x plus, then we will add the right side. And we'll finish until x plus equals the old x plus. If x plus doesn't change or remains the same, then we will exit this loop, and now the last or the final result of x plus is the closure of x under R. Okay. And we will talk about the closure, the relation between the closure of x plus and the super key in the next video. So stay tuned.